just like numbers have operations, like we can add numbers, subtract them, multiply them, sets can have their own operations. They're not quite the same. They have different symbols. But that's what we're talking about here a little bit today. That is the set operations. The first one let's talk about is it's called the union. And nicely, so what it is, like when I add numbers, I'm adding two or more numbers, but in set operations, I'm operating on two sets, so the same idea. So this symbol for union, nicely, it looks like a U. So we read that A union B. And what the union is, A union B, is the set of elements in A or in B. The set of elements in A or B. Now, may have a little bit of question about that word, but here's what it means. Another way to put it, A union B is everything in A combined with everything in B. So you're combining the two together. You're just dumping all the elements of both sets together. The union. You're unioning them together. Everything in A combined with everything in B. That's known as the union of A and B. Okay? All right, so let's all right, so let's just put a couple of sets over here and work with them as we go along here. All right, so let's say A is 1, 3, 7, 10, and B is 2, 5, 7, 10, 11. All right, so just straight up, A union B there. You know, if we physically did it, we would just take all these elements and all these elements and put them together. However, in sets, does duplication matter? No. And so we might as well just say, well, here, if I put all these elements, I'd have 1, 3, 7, 10. I'll just do it. All right. And then B, I mean, this is probably not how you do it, but just to make a point here. All right. So if I just took everything here and everything here, all right, that dumps them together. However, that's probably not the way we'd write it, right? For one thing, I don't need to write things twice because in sets, duplications don't matter. And then also here, we probably put them in order. We like usually things in order, most of us anyway. But yeah, so we'd say it's 1, 2, 3, 5, 7, 10, 11 would be probably the best way to write that. With me? I mean, that we're just dumping everything together. And I mean, I guess technically that's okay, but we would probably prefer this. Okay? So that's the union. Everything in one combined with everything in other. Intersection is the second one here let's talk about. Okay? And symbol-wise, it's a little, I mean, union, U. Intersection, its symbol is upside down U, or doesn't really look like an N, so intersect, but it's upside down. Okay, the arch symbol, probably what it most looks like, but yeah, that is, it's the set of elements in A and B. And the idea there is that's just the elements that A and B have in common. It's the common elements. Or another way to think of it, it's what is in both sets. It has to be in A intersection B, that set, it has to be in both sets. Not just one or the other, it has to be in both. It's what they have in common. Like, think of the intersection of streets. When we say the intersection of streets, what do we mean? Well, it's where street A meets street B. It's what they have in common, right? That's what we mean by the intersection of streets. Same thing in sets. The intersection of sets is what A and B have in common. All right, so over here on ours, that's going to be, in most cases, a much smaller set, because the only thing in A intersection B here would be what? For these two sets right here. Well, they don't have one in common, or two, or three. First one I see is 7, don't you? 7's in both of them. And it also had, both of them have 10. So those two are in the both sets. So those two are the elements in A intersection B. Okay? All right, then there's one more set operation. It's called the difference of sets. And this one is the only one that we'll talk about anyway that sort of looks like an operation we're familiar with. That looks like A minus B, isn't it? Doesn't it? Well, it is sort of that, but anyway, this is what it is. A minus B, A take away B, is the set of elements in A that, there's a second part though, that are not in B. You'll see how maybe this works here. I'll show you how this works. So it's a set of elements that in A that are not in B. Just see why we might think of it as A minus B. Yeah, and like I said, the way I like to think of that is A take away B or A minus B. So it's elements of A. Let's do this one. So it's elements of A take away any that are in B. So A take away B or A minus B. The way you might say it. So it's the elements of A minus any that are in B. Okay? All right, so here's how I like to look at this. All right, so let's do our two sets here. A take away B. Yeah, the way this works, here's the way I like for you to look at it. I'm going to start with set A. Okay, so let's just put A set here. It's A is 1, 3, 7, 10. Because you're not going to get anything other than what's in A in this set. Because it's A take away B or A minus B. You see what I'm saying? A is what you got. And then I'm going to take away from it. So let's start with A. Now, what do I take away here?
7 and 10.
7 and 10. So take away 7 and 10, what do you got? 1 and 3. 1 and 3. So you start with A, which is 1, 3, 7, 10, and take away the ones that are in B. So aren't 7 and 10 in B? Yeah.
Okay, I got it.
Now, you might notice here there's a couple of elements that are not mentioned when I did this. That is the 2, 5, 10, 2, 5, 11. Well, they're in B, but they didn't start out in this set because they're not in A, you see. So it's only elements in A that I get out of this, minus the ones that are in B. Okay, so I don't put any others in, I just take away from that. All right, now, this one is special, this set operation, because, if I switch these two around, if I asked you what is B intersection A, what would you say that is? What does B intersect A? Well, it's what B and A have in common. It's still 7 and 10, isn't it? Because it's still the same two sets, I'm just intersecting them, writing in the intersection the same, opposite way around. So those are the same. Same thing for B union A. B union A would be the same because it's still unioning the same two sets. But let's look at B minus A. B minus A. What would we have for B minus A? Well, I switched them around, and so going with what we talked about. So in this case, what do I start with, element Y? I start with B. So I start with B, which is 2, 5, 7, 10, and 11. Okay? Start with B here. That's going to change it up, isn't it? Now, take away A. So take away any that are also in A. What do I take away? Well, 2 is not in A, 5 is not in A, 7 is though, so I got to take that one away, don't I? 10 is in A, so I got to take that one away too, and 11's not. Okay. So this starts. This set winds up being 2, 5, 11. So is the difference the same? Can I switch it around like again, the union and intersection? No. I can't switch it around to be the same set. When I switch it around, it's different. And that, if you remember a little bit about your terms, that's, if you can switch them around to be the same, it's called commutative. You don't have to know that, but just FYI there. The difference of sets is not commutative. You can't switch it around to be the same. Switching around changes it, usually. All right? Are there any questions on that? We'll come back to these and do a few more. So, but the other thing I want to mention here to begin with on these set operations is also to talk about what are known as Venn diagrams. Venn diagrams give us a way to visualize sets, I guess, one way to think of it. Okay, so for a Venn diagram, what you start with is you start with a rectangle. And the rectangle represents the universal set. So everything in the rectangle, that's our universal set. All right, then sets themselves, like A and B, we draw those in as circles or ovals. So set A would be a circle, set B would be a circle. Now, sometimes there's overlap, so we usually draw them interlocking like that. So this is a what's called a two-set Venn diagram. Okay. Now, let's. One thing you can do with these is shade them. We'll do some other things with them, but let's shade, well, let's just start with this one. We hadn't talked about the complement yet. That's a complement. It's what's not in A, right? So if I shade the set A complement here, of course A is the A circle, everything in the A. So what is A complement going to be if I shaded it? Well, one way to think is just cover up the A circle and shade everything else. So here, if I shade A complement is everything that's not in A. That's what the complement is. It's what's not in A. So A is the circle, so what's not in A is everything outside the circle, you know, this little part of B, moon shape there, B, and then the outside part of the circles, right? So if you have pencils, probably better to, easier to, a little nicer shading, but you just kind of draw lines like that if we want to. Okay, so that would be A complement. So everything in this part and everything on the outside. That'd be our shading of an A complement. All right? All right, so a few other sets here. What would you shade for that? What symbol is that? It's the intersection, right? That's the intersection, and the intersection is what they have in common. Well, when you go to a Venn diagram, it's the overlap, right? That's where they overlap. So the intersection of A and B is right here in the middle. Is that right? What about A union B? Well, the union of A and B, how does union work? Union is everything in both sets put together, right? So A union B is everything in A combined with everything in B. So I'd shade everything in A, everything in B. So yeah, it's everything in the circles. It's the union. And then, now, oh yeah, before I erase this. Looking at these two right here, and then thinking about this, do you see that the union, one of the parts is the intersection, right? Yeah, the union has the intersection in it. So they're not two different sets, they are different, but the union actually contains the intersection. So that's an important note. And then notice here also, right here, right, the intersection is a part of the union. So they're not exclusive in that regard, but, okay. I wanted to mention that to you. I'll erase those. All right, then, the other two, the difference of the sets, A minus B, A take away B. That's what's in A but not in B. So what part is that? Well, A minus B is what's in A but not in B, so it's a little moon shape. And then B minus A, just the opposite there, if you will. It's what's in B but not in A. So, whoops, I'm going to do that. So put them in the same order. I guess we could have done it that way. B minus A would be what's in B but not in A. So wouldn't that be the moon shape over here? Yeah, it's the kind of the other side of it. All right, so that's a little bit about shading of Venn diagrams, the basic sets anyway. And we'll come back to Venn diagrams later on, but is that all right? Any question or concern?